In this video, we're going to talk about simultaneous equations. What are simultaneous equations? Basically, your objective is to find an intersection point. So you're looking for a point, so you need to have x and y coordinates, and this is when both of your functions will be crossing each other or intersecting with the proper math terms. There's three types of solutions. So you could have two functions, two straight lines that are intersecting at exactly one point. So this is going to be one solution. You could have no solutions. So if you have two lines that are parallel to each other, so they have the same slope, they're never going to intersect. So it's no solution possible. Or you can have an infinite amount of solutions. Now, this happens when you have coincidental lines, which means that the two lines have the exact same equation, same slope, and same y-intercept. Most of the time, we'll have a situation where we're actually looking for an intersection point, so we're looking for this unique solution. There's three methods of solving which we're going to be using in this course. The two first methods are algebraic methods, so substitution and elimination. Those are the methods you should have been using in previous math courses, and we're going to have a little revision of how to use each of them. And the second method is graphically. So graphically is something that we can use in this course, and we'll talk about the two different ways that we can use our calculator to solve simultaneous equations. One of them is going to be using the apps, and the other one is going to be graphing both functions and finding the intersection point. First, let's talk about substitution method, which is our first algebraic methods. The steps that we're using in order for doing substitution is we first need to isolate one variable in a first equation. It could either be x or y. We're then going to substitute this expression into this second equation. We're going to solve for that variable. We're going to find the other variable using our answer from step 3. And then, of course, our final step is always to write our solution as a coordinate, so the x and y. Let's do an example to start. If I have these two functions, y plus 4 is equal to 3x, and negative 2x minus y is equal to negative 1. I graphed it for you on the right-hand side, however, it's not always going to be given to us. Let's try and use substitution method in order to solve this question. First step is to isolate a variable. Now you can use any of the two functions. It doesn't matter which one you want to choose. I chose the first function and I'm isolating y all on one side. So I subtracted 4 to both sides. I get y is equal to 3x minus 4. Now I take this expression of 3x minus 4 and I replace that as y in the second equation. So making sure that y is replaced by the whole 3x minus 4. Notice that there's a negative sign in front of the y, so this should be distributed to every term in this expression. So what we're going to get is negative 2x minus 3x minus 4. Notice that I put this in brackets, and that's equal to negative 1. I distribute the negative, so I get a negative 3x and a positive 4. And then from here, I combine like terms, negative 5x plus 4 is equal to negative 1, and I get an answer where x is equal to 1. That means that I have the first x value, and I'm looking for the coordinates, I'm looking for the y value. I replace x in either of the two equations in order to find y, and I get that y is equal to negative 1. Therefore, the solution to this problem is that the intersection point is 1 and negative 1. And this was for substitution. Now let's look at the second algebraic method, which is elimination. In order to use elimination, we first need to make the coefficients of a variable, this could be x or y, the same in both equations by multiplying by a factor or factors. Then we need to add or subtract the equations together in order to eliminate that variable. We're going to isolate the variable. We're going to solve for the second variable by using one of the two original equations. And then we're going to find the coordinate. Let's look at an example. If you have x plus 2y is equal to 8 and 2x plus 3y is equal to 14. Again, I graphed it for you. It's not going to be given in the IB. So looking at these two equations, what we can notice is that by multiplying the first equation by 2 everywhere, we're going to get the same coefficient for the x variables on both equations. So that's going to be my first step for elimination. I'm going to decide to multiply this equation by 2 everywhere. So multiplying by 2, I'm going to get 2x plus 4y is equal to 16. And then I'm going to rewrite the second equation the way that it was presented already. In order to eliminate this x variable, I need to subtract the two equations together. So 2x minus 2x is gone. 4y minus 3y is 1y. 16 minus 14 is 2. So I get y is equal to 2. Now that I have y, I need to go and replace or substitute y into one of the two equations to find x. So I chose the original first equation, replaced y by 2, and I get that x is equal to 4. So the intersection point is 4 and 2. And this is how we use elimination method. The third method, which is the one that we're using the most often, is we're either going to be using our graphing calculators, we're going to either be using the apps or the graphing intersection. And let me show you how you access to each of these. If you want to use the apps, you're going to go onto your calculator, click on apps, and scroll down to find PolySimp 2. Now, it doesn't have to be the 7th option. Depending on what calculator you have, it could be the 3rd or the 9th. Every calculator is different, but you should all have this app. When you click on this, you'll see Polynomial Root Finder, which we'll be looking at when we do our quadratic functions. But for now, we're looking at the second option, which is Simultaneous Equation Solver. I click Enter. And then in Simultaneous Equation Solver, they ask me how many equations I have, how many unknowns I have, and then the rest of the information we won't play around with. So this one asks for how we want the answer to be written, so either as decimal or scientific notation, and then we won't play around with the float either or the degree. And then if we have two equations and two unknowns, we need to click on the next button, which is the graph button. And then they're going to give us the format in this way. So in order to solve this, we need to have both equations set up in this way, where you have the x and you have the y on one side and all the number terms on the second side. So that's the first method, using apps. We're going to be looking at an example right after this. The second method is graphing it. So in your graph, you go y is equal to, you would put in your two equations. Now making sure that the equation needs to be in the form y is equal to mx plus c. And then you're going to graph it, and then you're going to find the intersection point. So second function, trace. Intersection point is the fifth option. And you're going to click on the first curve, which is the blue one, enter. Second curve, which is the red one, enter. And then you're guessing the intersection point. You can just click enter anywhere, and they would give you the intersection point. Okay, let's do some examples to use any of these two methods. First example, we have the following system of linear equations. Now we have a situation here where we have three different equations. So this is the perfect question in order to use our apps, because the equations are already set up in a way where we have all the number terms alone on one side. In your apps, you need to make sure you choose that you have three equations and three unknowns. We're going to click on next, and then we need to insert the coefficient in front of each one. We have negative 2x, 1y, and negative 1z, and that is equal to 3. For the next equation, we have 1x, we have 4y's, and we don't have any zeros, so we keep the 0z, and that is equal to negative 2. Next equation, we have 3x's, 2y's, and 5z, and that is equal to 0. In order to solve, you need to click on the graph button just under the solve, and you get the following answers. If you don't like it in decimal form, you can always click the graph button again, and that's going to change from fraction to decimal or vice versa. And this is how you would find the three-dimensional intersection point for this system of linear equations. The next example is the INT Fitness Center charged one-time joining fee of $100 and then charged $2 per visit. Develop a model for this situation. So we have a situation where we have a one-time joining fee, 100, and then we're adding $2 per visit. So first I'm going to identify that my x-coordinate is going to be the number of visits. And then my cost, C, and I'm going to have the cost is equal to 100 plus 2 times x. And this is going to be the model for part A. Part B, use your model to find the cost for 20 visits. So part B, 20 visits, that represents my x. So the cost was going to be 100 plus 2 times 20. And I can do this into my calculator. 100 plus 2 times 20. And I get $140. Part C, draw the graph of your model. Now we're going to draw the graph in our graphing calculator. So we have 100 plus 2x. And we're going to graph this. If we can't see it right now, that means that our window is not appropriate. So we need to think a little bit about our window. We have a linear function where the y-intercept is 100. So that means that the y value, so the y-axis, needs to start at 100. We have a positive slope, so this is going to be increasing. So I'm going to go onto my window, and I'm going to increase my y minima. Nothing under 100 is interesting to me, so let's put it at 90. And then everything over 100, so let's put that to 200 to start with. And we're going to see the graph. Good. So now we have something that's a little bit more appropriate for us. We see the y-intercept, and then we see an increase. Let's go to part 2. A visitor of the INT Fitness Center decides not to buy a membership and instead just pays daily. The first cost is 12. At the end of the month, she visits 5 more times and pays a total of 60 for those 5 visits. Develop a linear model for the total cost of the visits. So in order to know the cost of every visit, we know that the first one is 12, but then we have 5 more visits, and these total of the 5 visits was 60. So let's figure out how much she's paying each visit. So 60 divided by 5, if we do that into our calculator, we should get 12. So in this question, even though the first visit is 12, we're not exactly sure if all the other visits are $12 as well, but now we confirm that all the visits are in fact 12. So that means that we're going to have a function where we're paying 12 every time we visit. So the model for no membership is 12 times the number of visits. E, use your model to predict the cost for 20 visits. Now we did that in our first question. So D is equal to 12 times 20. Let's see how much this costs. 12 times 20. It costs us $240. A lot more than if we had the membership, obviously, right? Okay, F. After how many visits is it better value to buy a membership? In order to answer this question, we're going to need to compare our 2 functions together. In order to compare the 2 functions together, I'm going to graph each of the functions. So the second function is 12x. I'm going to graph both of these. And I notice that there's going to be an intersection point. Right now, my window is not big enough to find the intersection point, so I need to increase the x maximum. So x maximum of 10 is probably not enough. Let's increase that to 20. And now we see this intersection point. So let's find out when both of them are equal to each other, and that's going to help us figure out when the other one is better value. So second function, trace. Intersection is our 5th option. First curve is blue, second curve is red, and then they ask us to guess the intersection point. We can just click on enter because there's only one intersection point possible. So for F, we're going to write on our piece of paper is that the intersection point is 10 and 120. Now the question asks, after how many visits it is better value to buy a membership? Well, at 10 visits, it's equal. It's the same if you do the membership or no membership. So what we're going to say is starting at 11 visits, this is going to be better. Last question for today. The table alongside shows the quantity V of air affected by smoke after T seconds. V and T are connected by a cubic model, which is of this form. Find the coefficients of A, B, and C. Okay, at this point, you're probably going to ask me, okay, Miss, you said we're doing linear functions. Why are we introducing cubic here? Well, there's a way of using this data to create linear equations and solve the system of linear equations. Each of these coordinates here represent a different coordinate that I can then put into my function. So I have a t and I have a v. If I look at the first coordinate, which is 1, 2, I can create the equation where v is 2 is equal to a times 1 cubed plus b times 1 squared plus c times 1. If I simplify this, 1 cubed is simply 1, so I get a plus b plus c as my first equation. And then I repeat the same for the other two coordinates. So I get 4 is equal to a times 2 cubed plus b times 2 squared plus c times 2. If I simplify this, 2 cubed is 8, 2 squared is 4, and then 2. And then the last one, we have 12 is equal to a 3 cubed plus b times 3 squared plus 3. So 12 is equal to 27a plus 9b plus 3c. So now what I have is I have 3 equations and 3 unknown, 3 linear equations. And they're all in the format that I can use the app in my calculator to solve this. So I'm going to go to apps and I'm going to find my polysim 2 simultaneous equations. Now I have 3 equations, 3 unknowns, and I'm going to click on next. My first equation, all the coefficients are 1 in front of the x, y, and z. X, y, and z refers to A, B, and C in our situation, and all of that is equal to 2. My second equation, I have 8, 4, and 2, and that is equal to 4. Third equation, 27, 9, and 3, and that is equal to 12. And then I can click on solve, and I get the values for A, B, and C in my situation.